In Unit 2, we did factoring with quadratics. We're going to bump that up with polynomials, so we'll be looking at higher degrees. I've given you examples of the different types of factoring here, and we've gone ahead and just shortened them. So greatest common factor, you can just use GCF and so on for the different types of factoring. In the homework, you're going to label what factoring you use, so make sure that you look at those and know what each one of those are. I would also use your factor sheet that I gave you in Unit 2, as well as I gave it to you again in the note packet for this unit. And it tells you step by step how to factor stuff. Let's go ahead and look at example 1. First thing you should do on your factor sheet is see if they have a greatest common factor. And this does, so I'm going to factor out a 2. So I'm going to divide each of these by 2. And so you'll get x squared minus 5x squared, or x cubed minus 5x squared minus 2x plus 10. So we used greatest common factor. And then notice they have 4 terms here. So under 4 terms, the first thing you should look at is grouping. So I'm going to underline each of those. The 2 stays on the outside. This first group has an x squared in common, and you're left with x minus 5. The next group, there's a minus here, so I have to factor it out. So I'll get negative 2, and then I have x minus 5. And now each of these have an x minus 5 I can take out. And that leaves me with x squared minus 2, and I still have a 2 on the outside. So I use greatest common factor, and I use grouping for this one. On the next example, I have no greatest common factor here, so there's nothing I can factor out. There are 4 terms, so 4 terms you're going to use grouping. The first group has an x cubed, and that leaves you with x plus 2. And I have a negative here, so I need to factor that out, so that's going to be a negative 1. And then you're left with x plus 2. These have an x plus 2 in common, and that leaves you with x cubed minus 1. X cubed minus 1 might go further because this has a 3 as a degree. This is a linear term, so once it's a linear factor, you're done factoring it as long as you got the greatest common factor out. On this one, there are 2 terms. It's not a sum or difference of squares, but it is a difference of cubes on that one. So difference of cubes. And if you look on your factor sheet for difference of cubes, you'll take the cube root of each of those, and then you'll square this, multiply them together, so that'll give you 1x, and then square the last term. And the signs are same, opposite, always positive. So same, opposite, always positive, and you're finished. That pattern is in on your factor sheet. For example 3, they do not have a greatest common factor. There are 4 terms, so I'm going to group. So group. The first group has a y in common, and I'm left with x minus 5. The next group has a negative 2 in common. I'm left with x minus 5. These each now have an x minus 5. And when I take the x minus 5s away, I'm left with y minus 2. Those are both variables to the first power, so I have linear factors here, and I am done. So I just used grouping on that one. On number 4, I do not have a greatest common factor, so I'm going to look at how many terms then. I have 3 terms. It's not a perfect square trinomial, because 6x squared is not a square, and neither is -1. It does not have a leading coefficient of 1, so I'm stuck with split the middle on this one. So I need something that multiplies to the product of the squared term and the constant. So I need it to multiply to -6, and I want it to add to -1. And the numbers that do that are -3 and 2. So I'm on split the middle on this one. So we'll go ahead and label we're using split the middle. And so this is now 6x squared minus 3x plus 2x minus 1. It does not matter what order you put those 2 terms in the middle. And then split the middle has grouping inside of it, but we're still just calling it split the middle. So this first group has a 3 and an x in common. And that leaves you with 2x minus 1. The next group does not have anything but a 1 in common. I'm going to put that 1 on the outside. So you still have 2x minus 1. So factor out the 2x minus 1, and that leaves you with 3x plus 1. When you forget to put this plus 1 on the outside, some people just put 3x here and forget that plus 1. So I would go ahead and put the plus 1 on the outside on that. Example 5. They do not have a greatest common factor. There are 2 terms. It is not a sum or difference of squares, but it is a difference of cubes. So difference of cubes. So look up the difference of cube pattern. You take the cube root of each of those, so x and 3, square the first term, then multiply those together, square the last term, and the signs are same, opposite, always positive, and you're done. Even though this is a square, if you've done a difference of cubes or sum of cubes, that will not factor. Example 6. They do not have a greatest common factor. It is not a sum or difference of squares. We have 2 terms. It is a sum of cubes, though. Look at the pattern. You'll take the cube root of each of those. So that's 3x and 4. Square the first one. So 3x times 3x is 9x squared. Make sure you square the 3. Then you're going to multiply those together. So 12x. And then you'll square the last term, and that will be 16. And the signs are same, opposite, always positive. And example 7. They do not have a greatest common factor. There are 3 terms. It is not a perfect square trinomial because -8 is not a perfect square, but it does have a leading coefficient that is equal to 1. So I just need to find something that multiplies to -8 and adds to 2. And the numbers that do that are 4 and -2. And you just get to fill those in. So this is x plus 4. X minus 2, and you're done. So number 7, we're just labeling that one as unfoil. On 8, they do not have a greatest common factor. There are 3 terms. X to the 4th is a square, but 15 is not, so it's not a perfect square trinomial. I do have a leading coefficient of 1 now. So I'm just going to unfoil this one. So it needs to multiply to 15. And it needs to add to 8. The numbers that do that are 3 and 5. And notice this is x to the 4th, so it's going to be x squared plus 3 in here, and x squared plus 5. Those are both squared factors, so we have to see if I can do anything with those. I don't have a linear factor, I have a square inside my factor. Is this a sum or difference of squares? And it's not. It's not a sum or difference of cubes either. Same thing goes for this one. Neither of those will factor any further. If this had been x squared plus 4, I would have a sum of squares. Or if I had an x squared minus 4, that would have been a difference of squares, and I could have still continued. But these are not sum or difference of squares or cubes, so we're done at this point. Number 9. I have two terms. They do not have a greatest common factor. So under two terms then, try sum or difference of squares. Nope. Sum or difference of cubes, and this is a difference because it's a subtraction, and those are both cubes. So this is a difference of cubes. Take the cube root of each of those, so 2x and 5. Square the first one, so that's 4x squared. Multiply those together, that's 10x. Square the last one, so that's 25. And then it's going to be on the signs, same. So same sign that you have there. Opposite, and the last one is always positive, and you're done. So you just need to memorize that pattern, and that pattern's also on your factor sheet. This will not factor any further. On number 10, they do not have a greatest common factor. There are two terms, and this is a sum of squares. And if you look at your sum of squares pattern, take the square root of each of those. On the sum, though, you're going to have the i's. One is plus and one is minus. And that's your final answer. On the next one, I have, again, two terms. I don't have a greatest common factor. However, I have a sum of squares again. So I'm going to square root each of those. So 4x and 3. On the sum of squares, you'll have the i's. One of them is plus and one of them is minus. And on our last example, I have two terms here. I do not have a greatest common factor. But on this one, this is a difference of squares. So I square root each of those. That's going to be 2x squared plus 5 and 2x squared minus 5. One of them's plus, one of them's minus. And the difference between the sum of squares and difference of squares, if you have a plus here, you have to have the i's. But you'll have one plus and one minus, and the i's are only on the sum of squares. On the difference of squares, you do not have the i's. It would be possible that these, since these are squared here, could go down further. So if I had ended up with a square here and a square here, I would have to continue. I'd have a sum of squares. And this could have been, if these were both squares, a difference of squares. And I would have to continue going on. Some of the homework, you have more than one step before you're done with it. I am finished with notes.